Hi guys, glad you're back for lesson 2. Hope you've did your practice, your homework on the 4 trig graphs from the other video and the other notes. Please make sure you do that first before you try to attempt this one. So what we're going to do now is we're going to take those 4 trig graphs, tangent, cotangent, secant, and cosecant, and we're going to adjust their period and phase shift them. So remember, the periods were a little different for tangent, cotangent, secant, and cosecant. Tangent and cotangent's period is only pi long, and they go from different places, from starts to finishes. And then cosecant and secants were still 2 pi long, just like sine and cosine. All right, so keep that in mind. Maybe have the notes you took from the lesson already, the beginning of the first one on 5-4, maybe have those notes in front of you. And of course, your unit circle. And I guess that's about it. So you ready? You got the notes? Come on, put your phones away. Let's go. All right. So first we're going to apply, stop. My daughter's laughing at me. First we're going to apply the tangent. Let's see what we got. Let's see what information is written there. Oh, I didn't click draw. 2 seconds. Got it. All right, so what do we have there? We have, oh, I don't like, oh, let's pick a different color. Oh, fun. Okay, sorry. So how do I make that go away? I don't know how to make that go away. Oh, did it. All right, so what do we have happening here in example 1? I see we have a 2, and maybe you need your reference sheet out too. So the 2 represents our B. Remember, our B is what changes our period. A period of tangent, super light. A period of tangent, remember, is found by pi over b, not 2 pi over b. So that means this period for tangent is only going to be, no pun intended, pi over 2. A normal period of tangent is pi in length, so this one's shorter. And then, remember this over here, we did this with sine and cosine already. That is what phase shifts our graph. Remember, that means it's moving left and right, the entire graph. So since it's a negative pi over 4, that is less than 0. I'm getting this from my reference sheet. Pull that out. That means this graph is going to move to the right. It's a little messy. I apologize. I'm still learning. To the right, pi over 4. Okay, pause if you need to. Get caught all up on that. So the first graph we're going to graph we're going to graph this in 2 steps. Okay, I'm just showing some separation here. Okay, we're going to graph this in 2 steps. The first graph we're going to just graph is tangent of 2x. We're not going to do the phase shift. We're going to do everything but the phase shift here. So a normal graph of tangent is from negative pi over 2 to pi over 2. That is pi long. This graph we need to be only pi over 2 long. So think of it on both sides. If you put both sides of a normal graph of tangent from negative pi over 2 to pi over 2, and you're going to move it in both sides, not just one or the other. You're going to move in both sides equally. Okay? So what plus what would give me pi over 2? Pi over 4. So our graph of tangent starts at negative pi over 4, and it ends over here at pi over 4. Think if you add a fourth and a fourth, you get a half. So that is pi over 2 long. All right, so now we mark in here, we mark in here. Again, I'm right now looking at my parent graph of tangent. I see where it starts, there's an asymptote. Excuse me. And where it ends, there's an asymptote. Okay? And then in the middle, I'm going to just count this as 1. We'll count this as negative 1. And so we put a point here, a point here, a point here. And it looks something like that. All right. So that was just 2x. We didn't phase shift anything. So the phase shift part says we have to move to the right pi over 4. So you ready? Hard question this first day back to school. If you're doing this today on Monday, if not, whatever your first day back is. What is negative pi over 4, this point right here, plus pi over 4? That's 0. So this asymptote, right here, see where I'm pointing? This asymptote moves on the 0 line. Again, I'm going to put it a little off just so we can see it. Uh-oh. Pause. Okay, sorry about that. Yes, we still have a house phone. Really not sure why, but we do. So we were moving all these points on this graph to the right, pi over 4. So we started with negative pi over 4 right here. Negative pi over 4 plus pi over 4 is 0. So we move the asymptote there. What is pi over 4, this asymptote, plus pi over 4? Here's your unit circle. So pi over 4 plus pi over 4 puts us out here at pi over 2. Okay. And then the middle mark. This looks like the middle mark right here is 0. 0 plus pi over 4 puts me at pi over 4. And I'll just mark these other two parts here. I don't really care what they are. And here is 1 and negative 1. So it goes here, here, here. And there's the graph, phase shifted to the right, and the period changed. Okay, questions? Okay, let me know if you got any. Moving on to example 2. Got lots of stuff happening here. We have an A that's equal to a half, which means it gets vertically shrunk. I don't know, I teach math. Vertically shrink it. We have a B of 2. And so remember that changes our period. You find the period of cosecant, the same as sine. So that means our period becomes just pi. And we have right here some phase shifting happening. So pi over 4 is greater than 0. So that means we're going to the left pi over 4. Okay? So again, we're going to graph it in 2 steps because I want us to be showing the phase shift. So the first graph we're going to graph is just cosecant of 2x. So that means we're just changing the period. Again, I have right here in front of me, I know you can't see it, and I'm not really good yet to be flipping back and forth on the screen. I'm not there yet, so on my second time. Okay? We're all learning. Cosecant of 2x. So I'm looking at the parent graph of cosecant, which is normally from 0 to 2 pi, but now we know ours has to go only out here to pi. And then remember, break it into your 4 equal increments, so halfway would be pi over 2, and then I'm not going to label these, that's too much. So if I'm looking at the parent graph of cosecant, and I have my 5 tick marks, right? In this case, it would be 1, 2, 3, 4, 5. Which numbers are my asymptotes at? Look at the parent graph. I have 3 asymptotes. They're at the first one, so that's here. They're at the third marker, that's here. And they're at the last marker, that's here. Okay? And I'm just doing 2x, I'm not changing anything else, so we'll call this guy 1 and this guy -1. This is getting really crowded, sorry. And so cosecant, we have a point here, and it goes up like that. And we have a point here, and it goes like that. Okay? Now we're going to phase shift it and vertically shrink it to half. Remember, vertically shrinking the half means you multiply your y values by a half. So this y value is at 1, 1 times a half, it would just move down to a half in this new graph. And we have to move it to the left, pi over 4. So let's move it. Let's move all the asymptotes first, and it kind of makes it clearer what the graph would look like. So this one's at 0. 0 minus pi over 4. I would just put this guy at negative pi over 4. So there's my first asymptote. My next one is at pi over 2. Pi over 2 minus pi over 4. Pi over 4. So here's pi over 4. Here's my other asymptote. Pi minus pi over 4. Three pi over 4. What happened? I lost it. Oh, I think there's a button. I clicked it. Sorry. So 3 pi over 4. There's my last asymptote. Then you kind of see it kind of makes it easier to look where the rest goes. Don't forget about the vertically shrinking by a half. So this was at 1. It's going to move down here to a half. And this was at negative 1. Negative 1 times a half. Negative a half. It goes here. Questions on cosecant. Okay. The last one. Secant. Okay. I have in front of me the parent graph of secant. Let's see what this guy's doing. So this says I have an A of 3. That's a vertical stretch. And then the only other thing he's doing right here is some phase shifting. It's a negative pi over 6. That's less than 0. I'm using my reference sheet. And that means I'm going to the right pi over 6. So my period, it does not change in this one. So a standard period of secant, looking at the parent graph, goes from 0 to 2 pi. So in this one, all I'm doing is applying the 3 of the vertical stretching. Looking at the parent graph of secant, look at your 5 tick marks. Where are my asymptotes at? They're at tick mark number 2 and tick mark number 4. And I have to go up here to 3 for the vertical stretch. 1 times 3 is 3. Negative 1 times 3 is negative 3. And 1 times 3 is 3. Okay? All we're doing over here is phase shifting it pi over 6 to the right. So let's move our asymptotes first. This is pi over 2. Or you want to move the middle. Oh, let's start with the beginning point. Sorry. So 0 plus pi over 6. This guy moves to pi over 6. Then 1, 2. Let's just make them first. So something like that. All right, the last one. 2 pi plus pi over 6. How are we going to think of 2 pi? We're going to think of 2 pi as 12 pi over 6. 12 pi over 6 plus pi over 6 gives me 13 pi over 6. Oh, and we said this was pi over 6. I never wrote it. Sorry. And then the middle guy. Our middle guy is pi. What is pi plus pi over 6? So something like 7 pi over 6. I just used my unit circle. Okay. Throw in my asymptotes at 2. The second tick mark. And the 4th tick mark. Sorry, that got messy. And I know this guy goes like this here. This guy is down here at negative 3. 1, 2, 3. And this one's up here at 3. Okay? Okay. So for this assignment, again, it's posted lots of places, but we'll write it here like we do normally do. 438, 35 to 42. And make sure you show the phase shift. Let me know. Email me. Call me. Text me.